All right, this is it's 5 p.m. now. Let's get started so that we can end in time. So very warm welcome to everybody on this session today on Kubernetes. Here's a quick slide about myself. Some of you may be familiar with me. For those of you who are not familiar with me, this is who I am. I'm Abhishek Kant. I have about 18 years of experience in the various technologies. I've worked with Microsoft, then was working with Progress Software. Many of you may be familiar with Telerik products, Telerik UI controls, RAD controls, Kendo UI. So that's the company that makes them, and we are still responsible for selling them in India and making this available to the developer community here. I'm also an MCT regional lead. I've authored a course on Pluralsight. You see my interests revolve around cloud computing, machine learning, and I've been an avid speaker, and my certifications, I think, are displayed there as well. So if you want to follow me on Twitter, that's Abhishek Kant. And if you want to drop me an email, my email is abhishek@gtmcatalyst.com. GTM Catalyst is the company that I am currently engaged with. We do a lot of cloud work, cloud consulting, cloud training, and we provide a ton of projects around machine learning as well. So what I'm going to do is I'm just going to run a few Docker commands so that the people who are not familiar with Docker may become familiar with it as well. So the first command that I want to show you is what is called as listing of the images. So there are two concepts. There is images and then there is containers. Containers are running instances of the images. So if I want to first check out what all images exist on my machine, I can simply say Docker images. And as you can see, I have a bunch of images already installed on my machine or available on my machine. And if you look at the size of these images, they may vary from just a few megabytes, as you can see. One is even smaller, to few gigabytes as well. As you can see, there is 1.75 GB here. So this varies in size. They can go really, really big. Also, if I want to see what are the running containers or containers that are running on my machine, I can use Docker PS. And as you can see, a bunch of containers are already running on my machine as well. So this is literally listing of the images. Now, if I want to run a container, the command simply is Docker run. And let's say I don't know what to type from here on. So the Docker containers or Docker CLI. So what I'm using right now is the command line interface. It also has very extensive help, as you can see. So when I said Docker run -- help, it gave me a list of parameters, commands, all that options that I can use to work with this specific command. Docker run is something that you will use quite often to make your containers run. So let's run a single container, Docker run. Let's run a simple Ubuntu container, for example. This is a parameter that I'm using, or an option that I'm using. I stands for interactive and T stands for connect to my terminal. And I can say probably something like Ubuntu. So what I'm going to do here is I'm going to actually run a container which is simply a Ubuntu container. So it's Ubuntu Linux. And probably what I want to do, because I want to log into it and do something about it, is run the bash command in there. So if you look at it right now, what you have is the Docker followed by run command, and then the option of IT, and then the image that I'm going to run from. Okay, so that's Ubuntu. And then I've got the command that I want to run with, which is bash at this time. Okay, before I just run this command, I had, so before we run this command, do we have Ubuntu image available on my machine? Let's check that out. In the images, you will see if I have an Ubuntu or not. I actually do. So as you can see, this is the Ubuntu image that I currently have. All right, so I do have an Ubuntu as you can see, an Ubuntu image here. I was just trying to kind of be able to highlight this for you guys. You will notice I have this Ubuntu image, but I really don't need this image as of now. So let me actually get rid of it. So the next command for you right now is going to be getting rid of these images because they are really big. So we can simply say docker rmi, which is remove image, and I can say Ubuntu. All right. Okay. It's probably been used somewhere else as well. So let me not force this for this time. Let's just continue using the Ubuntu container. And I was talking about the command that we can run. So this will be docker run -it, which is interactive and terminal, Ubuntu, and then the bash shell. So the moment I start running it, you will notice that it has come up very quickly, the bash shell. And right now I'm actually working with Windows, with Linux shell, which is the bash shell directly. So this is a full container by itself. And as I said, if this container is running, it should be listed also somewhere. So let's bring in another command window and try and see if we have this running. So just grabbing in another image for you, another command window for you. And as you can see, we have this one running our bash shell. Why don't we again take a look at the running images? And as you can see, once again, the Ubuntu image is now in the running state. So if I go in here, all right, so check this out. Sorry, that was a really big one. So that's the image we are running. And the container name is 827, which is the container ID to be exact. And the container is also given a name by itself if we don't give one, which we didn't. So that's the one that's been given by default. Now we can go in here and stop the running container or exit from the bash shell here directly. Let's do that exit. So since I have exited the Ubuntu shell, ideally the container should have terminated as well. Most of the beginners have a confusion about when do containers run, when do they stop, and so on and so forth. So the containers by default stop running the moment the command in there is executed, unless you make them run in a detached mode or a daemon mode, if you will. So since we didn't use any of those options, it should have been terminated. And as you can see, in the new list that we've done with Docker PS, there is no Ubuntu container, and to contrast it, there was one running earlier. There is also a command that allows you to see what all containers have run recently, which is using -a or all. And as you can see, I've got these two containers that are currently in the stopped state in the Docker on my machine. So I can remove these containers also, and to remove them, I can either use their container ID. So you will notice the container ID was the first column, 827, and I don't have to specify the entire container ID. I can just use the one that is enough to, or the number of characters that are enough to disambiguate this particular container ID on my machine. Similarly, I see another Ubuntu container running, or rather, it's in the stop state here, but it's still a container on my machine, which actually prevented me from removing that image earlier as well. So we've removed the two images, and now if we do the docker ps-a, you will notice there is no other container by the name of Ubuntu. So this should help you understand a little bit about Docker containers. Then there is Docker Ubuntu. So let's actually now try and run that command again. Docker, if you remember, docker rmi Ubuntu. Hopefully this should be gone by now. And yes, it's currently gone. Now, one of the key things that you also have to understand about Docker ecosystem is that it places a lot of importance on tags. So if you look in here, when it started to remove Ubuntu container, the first thing it did was it said untagging. So this is important in the Docker ecosystem. Tags are extremely an important aspect of an image that is created or maintained. So you should be careful of the tags and pay particular attention to tagging. While tags are generally considered as unstructured taxonomy, in Docker world, they are essentially very, very important. So this is a bunch of pre-built Docker file or Docker image that's available for you to consume directly. Okay, now most of you are developers, aren't you? And for you to work with containers, this is not good enough because this is just what is available in the image. As developers of applications, we need to be building our own images and pushing them up in the repository or running them on our enterprise apps and things like those. So now to make that work, which is to create our own repositories and create our own applications, we get to the concept of what is called as a custom image that we need to create for ourselves. Building container images, which is a custom container image, is not that difficult. And that's the second thing that we want to do right now. So let me bring in a quick Windows Explorer window for you so that we can create a new, all right, or we can just work with the existing command lines as well. Let's bring that in. Okay, so here we are. Okay, what we are going to be doing is probably create a simple node application, which will do literally nothing, but probably just say hello world or something like that. I don't want to make it too CLI focused, but because the Docker containers and the Kubernetes is essentially CLI focused, let's try and work with this also right here. So you've got all of these directories. Let's create a new directory isolated enough so that we can work with it separately. Let's call this directory mint node app. Right, that should work. cd mint node app, and as you can see, we get our directory right here. Okay, so let's see if I have node installed on my machine, which I do. So I should be able to quickly do an npm init here. So let's go and see. Yeah, that should be fine. And we are, I guess, good with this. Okay. So we've created our npm init, and now we have a package.json. The second thing that I want to do is probably create or use Express here. So maybe say npm install Express. So that should start installing Express on my machine locally. Let's see if that is going through. All right, and it has gone through. So let's bring in okay, so that's my Windows Explorer now. And now if you look at the structure of the application, you have the node modules, and essentially it's the Express. This is the package.json that we were able to generate, which is right here. And in here, you will notice all the things that we have put in. So dependencies, you will see we've only taken one on Express. All right, why don't we also probably start to use Visual Studio Code? Okay, let's try and do that. All I'm trying to do is probably just create a new node application here. Right, so let's open the folder. I guess it should have been selected. Okay. Okay, Mint Node app, and let's select that folder right here. Okay, give it a second to open. Okay, so now we can see that we have put in our application. Why don't we now create our node file? Let's call this server.js. Okay, let's see, it's creating right now. Okay, so we have server.js created. Now I like to copy in some code for you. So as you can see, our server.js got created here. I'd like to copy in some code, which basically illustrates a simple Express application. I don't want to spend too much time writing this application, so I have this pretty prepared for you. So as you can see, it's extremely simple, nothing fancy about it. All it is it's requiring Express. It's declaring the port and the host. So currently the port we're running is on port 8080. We've got Express, which we've instantiated, and then whenever we say something, well, we're going to say hello world, and then we are going to use any environment variable if it's going to be there. Now we haven't used environment variables at all, but let's just see what happens when this runs through. And then let's just save it. You've got this application running as well. All right, this is good. How about we run this application? And for those of you who are familiar with simply running this in Node, I could likely just probably try and say this, which is node server.js. And if I go into my command line, it's listening on port 8080. I could literally then go here and say local host port 8080. All right, so obviously our environment variable is undefined, which is fine for now. And we have hello world message that's rendered by our Express server. So this is literally how you have a simple Node application created. And as we've seen, running on our local machine, this runs just fine. All right, so we can exit out of this. And let's now, the first step to working with Kubernetes is to actually start to create a container. The way Kubernetes is that without a container, Kubernetes does not work. It's essentially, and we'll talk more about Kubernetes and the concepts behind it. I'm intentionally keeping the concepts a little low as of now, so that I can first get you to see what we are doing, and then we will try and read the concepts behind whatever we just did. Okay, so to make this work, to make this Kubernetes or to make this convert into a container, we're still not at the Kubernetes level. We're still at the container. We need to convert whatever we have just done, which is have a node dependency, get our Express npm package, and run our server.js. We need to start to write a Docker file. This Docker file is the one that will be responsible for creating our custom image. Okay, so that's our Docker file. And then in the Docker file, you have a little bit of commands that we can work with. And once again, I am not going to be spending too much time doing this. So I'm just going to copy paste. It's not too many lines. It's just, we'll go over these 8 lines very quickly, not too difficult. It starts from node, or it says from node :10. It means start from this base image. Now, every line after that, which is essentially a run or something, will create a new layer over the existing image that we kind of start with. So when I start with this node 10 image, it will bring down this image if it doesn't have it locally. In our case, I think it does. And then we are going to send or set up a working directory as user source app. We are going to copy our package.json, which is in our local file system. It is copy from to. So from local machine, which is package.json, we are in this directory. So from package.json, copy it into the container, wherever the current directory is. And as you see, it is the current directory. From there, we are going to do simply an npm install, which is what we would have done otherwise also if we had a pre-configured JSON or package.json file. Once that is done, till about here, we have created a new layer over the base image that has come through, which is the node image. Now, we are going to copy the rest of the artifacts, which is basically the server.js and package.json and things like those into, so package.json was already copied. So we're just going to copy over server.js from our local machine, local folder, wherever this is running, into the container, wherever the current directory is, in which case that's your working directory. All right. So we've copied these things over. And then we have the environment that we want to declare. So remember, in Node, we didn't use an environment. In this case, now we are specifying environment username as Abhishek. So that's what I'm going to say, user equal to Abhishek. And I'm going to declare that this container exposes the port 8080. So whenever this runs, we're making sure that we inform the container that port 8080 is being exposed. And finally, the command to run is node server.js. This is exactly the same command that we had run even here, node server.js. All right, so this is literally what we need to do to create a Docker file. And so we kind of can save it. All right, so here in the container, let's see if we have access to our Docker as well, which we do, as you can see. Now what we need to do next is to build the Docker image itself. So to build the Docker image, you have the command docker build. Now remember, I talked about tags being a very important aspect of things. So let's call it docker build-t, which is a tag. So we're going to give it a specific tag. Since it was called the Mint Node app, let's just call it the Mint Node app. But just as a part of convention, you don't want to use just the name. You want to probably, prepend it with the name of the user as well. So I'm just going to say Abhishek Khan. And I'm going to say the name of this container is going to be Node app, Mint Node app. And well, this image is getting constructed. It needs to know from which Docker file to make it and where is this Docker file. So currently I've just put a dot to indicate that my Docker file is located in the same folder wherever we are currently there. Okay, so that should start building our Docker container. This should finish literally a little quicker because we have the local or the Docker image of Node already locally available. So all it was left to do was to, if you see, it is very verbose. It's showing you what it did. It created and set this working directory. It copied the package.json from our local file system to the remote system. It continued to then do npm install. And from there, it did a copy of all the files, set the environment, and then it was indicating that port 8080 is exposed and the command line, or run this particular command. So at this time, we have the image created. There is still no running instance. So all we have here right now is a instance of an image created, which is not yet run. So remember the command that we used earlier to see which all images do we have. So you can say docker images, and here is the first one. As you can see, it says Abhishek Kant Mint Node app. Since I did not specify a tag, it automatically tagged it as the latest. So Abhishek Kant /Mint Node app has been created and is available in my local file system. And as you can see, the size of this is almost a GB, which is about 916 MB. So that node image was a really, really heavy image. And as you can see, this was about 911. So literally with all the work that we did, we just added about 5 MB to the image size. Okay, now the time to make this work or make this container run from the image that we have. So you remember our friendly Docker run. Now, this is going to be slightly different from the -it that we ran earlier. And that's because in this case, what we want to do is we want to run this as a daemon or in a detached mode, which is it continues to run in the background, as well as we want to expose the port, whatever is currently there running in the container, to be exposed outside as well. Now, to make that work, we've got to do -p. And let's use port 888 because we had earlier something like localhost port 8080 that we had used. So that was when we ran our node application locally. Currently, it's not running. So if I did a refresh, obviously, this won't work. So let's continue to map it down to what is the port that it currently should be mapping into. So whenever I'm going to type port 888 on my browser, that port is going to route it to or translate it to an internal port, port 8080. All right, this is good. What else? Well, I tend to use, because for our demonstrations, I tend to use the RM switch, which basically removes the running containers once they are stopped. So it removes it from, or it completely terminates it rather than just stopping it. So I'll use this switch --RM so that I don't have to kind of go ahead and clean up. You remember the detached mode I said, because this has to be running even when we exit out of this container. So it will be running in the detached mode. And what we need now is the image itself, whatever image we want to run as a container. So I think we had created the image mint node app. So we can actually use this as well. And there are a bunch of additional commands you can use. I'm not going to be using quite a bit of them. There are memory restrictions that you can place and things like those, but let's not do all of that. Let's just quickly run this image. And now we have a running container called with an ID 724. So that's what it's showing you. If you now do a Docker PS, you can now see that there is actually a running container with our image Abhishek Kant mint node app. And that's sort of the container ID. And it's available on port 888. So if I go back here and do port 888, I'm expecting to see the hello world Abhishek command. Right? So what we have here till about now is a custom Docker container that is running, and this forms the basis of moving forward into the Kubernetes world. So this is a single Docker container running on my machine. We stopped at seeing that we have the Docker PS, and we saw the container is running. And we also saw that if we stop this container now, it will essentially be removed or will go into completely a terminated state. So I will just say Docker stop 724 F6. Okay, let's just stop this container for now. It's going to take a little longer because it's not only going to just stop the container, but it's also going to remove it from the containers. So if I now did a Docker ps-a, you will notice that is not available locally as well. And this actually brings us to a very, very important concept in Docker, which a lot of people confuse it with. So let's focus on this Docker file once again. If you notice here, we have the Docker file, and it starts from node 10. And we have working directory set as copy, run, copy, and expose CMD. So this is not any programming language that you are familiar with. It's not, there is no, if you're working with Node, there is no JavaScript there. If you're working with .NET, there are no classes, no nothing. This is nothing to do with the programming language or the application language that you are actually using. So then what have we just done? Then if I'm saying that this is not programming language, so what is it? What have we really actually done? All right, so what did we just do? And herein, as I've said, herein lies a very, very important concept about containers by themselves. Now, if you remember traditionally, what we would do is this would be a server, whatever server this is a Windows server or a Linux server, whatever that is, it's just fine. On that Linux server, we would install our Node runtime, right? And I'm talking about a deployment of an application here. On the Node application, we would need to have whatever our files. So for example, in this case, JavaScript. And this is our typical machine, right? Now, this deployment, we have to have a Linux machine. There was a Node installation that we had done in JavaScript. This was done implicitly, which means you had to be told that I am deploying this, and you had to have this implicit knowledge about how to work with this. Okay, so this was an implicit deployment. Now, what we have done with Docker is change this into what we call as a declarative deployment. So we were declaring things, if you notice, and there was a configuration file to make that happen. So now what are we declaring? We were declaring what to do. In fact, we were declaring all the actions we would otherwise do whenever we are doing an implicit deployment, which is we took a Node application, we first installed npm on it and Node on it and things like those. From there on, from the Node application itself, we then copied all the files into JavaScript. And if you once again take a look at what we wrote in our Docker file, that's exactly what we wrote here as well in the Docker file. And in this declarative part, now you can think of it as a config file, like this is your configuration file, right? This is the configuration file that is saying how to do this deployment. And this is a bunch of your artifacts. So this is your JS file. Now, if you had a CSS file or whatever else you had, if you had more JS files. So these are your actual files or coding files, right? So these two together now are the deployment that would otherwise have been the implicit deployment. Now with Docker, what we've accomplished is the separation of the two. In this case, the configuration file is what we have as the Docker file. And as you can see, this is very different from the programming language itself. So if it is different from the programming language, does that mean I can do it for any other programming language? You of course can, which means if this was not a Node deployment, but let's assume this was going to be a .NET application. So you would have all your DLLs available, multiple DLLs, I believe, that you would have hosted and used a Docker file along with these independent artifacts to work with your Docker container. If it was a Java, you could have had a war file. I'm just going to draw this so that you know these are different technologies, and that you would have a Docker file again, which is a configuration file, which is independent of what we had here. But this configuration file would change once you're using it in terms of with Node application, with .NET application, or with a Java application. So it changes as we work through it. Let's now actually move into doing something with the Kubernetes aspect of it. So now what we have at this stage, and I'm going to clear all this. Hope this is clear now. So I want to definitely move forward and start to convert our Docker file and start to look at the container that we had created and make it into a Kubernetes application or Kubernetes cluster. So well, we have the Docker container running, and as I mentioned, this is only one such container. Now moving on to Kubernetes, or moving on, let's put it this way. What we want to do right now is to make this single container. We are sort of going to get a lot of traffic for this specific Hello World application because it is very, very popular. And we've started to get a lot of people using this particular application. So obviously, when you think about scaling the application, you have to start thinking about adding more hardware to it. So scale out, scale up are the two things that you can think of. Most of the times today, we talk about scale out. Whenever specifically we're talking about things like web servers and things like those. So what we want to really do is scale this out. And to do that, we will need to add more containers. So Kubernetes is that system or that set of, or is the architectural, not an architectural pattern, it's the system that allows us to run multiple containers as a cluster. So that's the simplest definition, may not even be as official as it should be. But what we want to right now do is whatever container we have, which we just created, and you saw us create that custom container, we want to be running that container as a cluster. So not just one container, but we want it to run like 2, 3, 4, 5, and whatnot that you've currently seen. Well, it's as easy as what we saw with Docker files, okay? What did we see about Docker containers, creating Docker containers? To make the Docker containers work, all you really needed was this specific Docker file. So let me just minimize these things once again. And as you saw, to make the Docker container work, all we needed was a Docker file. Oh, so somehow it increases the size. So that was just that Docker file that we had actually brought in. So let me rub that out and bring this back as the Docker file. Well, Kubernetes is equally simple. Well, how is it simple? Because to make, so ultimately what this led to was this one installation, right? Or one running instance. So all of this packaged together was a single instance, right? There we go. Now to make multiple such instances of the container that we have, we use what is called as the Kubernetes system that we are describing or currently working with. So if that was one instance, this is instance number 2, and so on and so forth. There can be instance number 3 and so on and so forth. Now, if all we needed to make the configuration file, all that we needed to convert our application into a Docker container was a Docker file, right? So all we need to really do to convert our one instance into multiple instances is another configuration file. So I'm just going to say, or break this into 3. The first one I'm just going to say is actually our app code, which is all whatever JS or whatever .NET or whatever DLL or whatever var file we had. We wrote our Docker file. So that's Docker file for you. And to make everything work in Kubernetes, all we need is another file called the YAML file. Okay. Now, once we create this YAML file, we would have converted, and then when we run it, we would have converted our single instance into a cluster, which is running multiple instances of the same container. Well, that in short is Kubernetes. There are various other concepts that we have, but let's actually try and do the same thing that we said, which is in our node application, we created a Docker file. We had it running as a Docker container. We are going to add just one more file, which is the YAML file, and it will become a cluster, which is a Kubernetes cluster. So let's make that work. All right, so now we have the Docker file. And as I mentioned, to convert this into a Kubernetes cluster, all we need is another YAML file. So let's just call it, what do we want to call it? Let's call it the Kubernetes dot YAML. Well, that's a YAML file for you. And all we are going to be doing is typing in some text, and that will bring about the work that we wanted for our single container to convert into a cluster. Okay, so how do we do that? And I've pasted in some code here. But just like Kubernetes, just like Docker container, this is literally all there is to it. Okay, I've just copied in some code. So let's go over step by step in this, and we will need to make some changes based on the name of the application that we have or the image that we have currently built. So let's check out the name of our image as well once again, listing our images. So Docker images, you will notice is, there we go, Abhishek Kant Mint Node app. Okay, so that's our image based on which we had created our container. Okay, so let's go over this. Now, as you will notice, the key aspect of it is the kind of deployment that we are doing. So this is called kind, and this is of type deployment. Don't worry if you do not understand this too much. It is going to come to fore very quickly. I want you to pay attention to this specific aspect, which is kind deployment. Then what we are going to do is look at this aspect, which is containers. Now in containers, I have to specify the image that I'm going to use. So I can just specify that's the image that I'm going to use, which is Abhishek Kant Mint Node app. And I can change the name of my running container also. It will be called Mint Node app as well. It is going to have the container, which is its exposed to port 8080. And then let's look at what are the other aspects. So this is the same as what you saw about the containers before. It's the same amount of detail that I have put in. Let's look at some metadata. So it's just metadata in terms of how do I identify what I have just done. So this specific action is called deployment action, which is deploy this application or deploy this container in the format that I want it to be. And it is just a selector. So this is all metadata. Well, this is important, replicas. So this says how many containers do I want in my cluster at this time. So I've said, give me 3 containers whenever we deploy this. So it will give you 3 replicas from there on. Once again, it is the Mint Node app, which is matching the label templates. So I'm just sort of setting up all the templates to refer to the new application that we have. So that's part A, which is a deployment. Now you have 3 clusters or 3 specific containers running in the machine. Now, all of them, if you think about it this way, they are independent. They're independent virtual machines, if you can think of it that way. They're independent containers with their individual IPs and things like those. But we are not going to be directly accessing individual machine, all right? What we want to be really doing is have something over on top of it, which we can go to that can help us load balance all of this. And to make that work, we have what is called a service. So this is another kind of Kubernetes artifact or an object. So the first one was deployment, which was responsible for maintaining the number of containers in the application. This service creates a layer over these different containers and makes sure that you get a single entry point or you get a load balanced point or a load balanced location, which can keep directing it to different individual containers from there on. Okay, let's continue to change that. And here is another important aspect. The type of this service is called node port. We will look at the concept a little later. And the selector is important. Now, this is the selector in terms of what all specific nodes need to be, or pods. I have not introduced that term, so I will stay away from it. So what all containers do I need to be creating this layer over? We're creating this one layer, which we are going to direct it to, and that's that layer which is the service layer, and that is going to encompass all the containers that are called or that are labeled with Mint Node App. If you notice, they are the ones that are labeled with Mint Node App, which is Mint on Node App, right? So your port, which is the common port, is going to be 31,000, and the target port, just like port redirection we saw with Dockerfile, the port redirection is at work here, which means when you type 31,000 on your machine, it's going to go into the container cluster and try and get to port 8080. Well, that's literally it. That's literally it. You have got a Kubernetes file going, and now we are ready to run this and in a Kubernetes cluster. Okay, so the runtime, once again, just like Dockerfile, the runtime has to exist on your machine. So the good thing about the Kubernetes desktop that I was showing you earlier is that it also supports running, I would say, quasi or single node Kubernetes cluster on your machine. And the command line, just like Docker, to work with all of this is called kubectl. And just like the Docker command, we can check if this kubectl file is running or not. Obviously, I wrote something incorrectly. Dash is probably what it does not need. So I can just simply say Kubernetes version. And here you can see it's giving me what is the client version of Kubernetes, what's the server version, and things like those. Okay, so we're good. Kubernetes is running here. How do I make these clusters now run? Well, actually, it's pretty simple. Just like one Docker command to make the Docker container run, there is only one command to make Kubernetes work wonders on your machine, and that is kubectl apply -f, which stands for what file, and you have to just specify the name of the file. So k8s.yaml, and let's just run it. Well, that's it. That's it. That's literally your containers have now been converted into a running Kubernetes cluster. But we don't know what just happened. We don't know what to do with it. And now here we need to navigate and see what all actually happened on our machine. Okay, kubectl is our gateway, just like Docker command was. Kubectl is our gateway into everything. Let's try and say get nodes. This is like the machine that it's running on. Well, currently there is only one machine, which is the physical machine that it's running. So it's called Docker Desktop, this machine's name. Let's see what all are the individual containers running. And the technical term, whenever you move into cluster for kubectl, the containers are now called pods. Technically, they're slightly different, but let's for now say pods. And as you can see, we had requested for 3 pods to run, and that's what you're seeing running, which is we have the 3 pods that are currently running based on what we actually requested. We requested for 3 replicas to run of the same application, and they're all running right here. Okay. We now also want to see what is the common service. So, well, here we go. That is your common service that is currently running, and it's available on port 31,000. Okay, so why don't we do and check this out? We go into our browser. If I can find my browser, that is. Yep, I think I can. And if I start to type localhost, hopefully 31,000, There you go. Hello world Abhishek is still functional. You remember our older container was at port 888 that we had stopped. Currently, we are running 3 individual containers, or pods to be exact, and all the 3 pods are going to be used in you can say round robin really, and that is what is leading us to this specific output. So 3 containers running and 3 containers are giving me an output, hello world Abhishek. All right. Now, once again, because the image is available locally, I don't have to actually go out and get this from any repository and things like those. But what you have is a working Kubernetes deployment. So you can see here, there are nodes. You can get a little more detail about what's going on by using kubectl describe pods, for example. Here, that's a lot of information, and each individual pod is described for you. For example, here we go. Whatever you want to see, it's right here. Here is the other interesting aspect of Kubernetes. To make any change into your deployment, which is there, you don't have to issue any other command than just modifying the file that we had earlier created. For example, we now want from 3, we only want, let's say, we want to increase it to 5 replicas. Okay. You don't have to do any other thing. All you have to do really, oh, sorry, that was not intended to be typed here. All you have to do really is use the same command that we had used earlier. Once again, kubectl apply -f k8s.yaml. But before I apply that, let's go back into the other window that we had. How about we look at kubectl get pods for that matter. There we go. You can see we have about 3 specific containers that are currently running. Just a second. So what we can do now is run this in the watch mode, so we can see if there are any changes that happen. Okay, so that's running. So currently, as you can see, there are 3 running. Now what we are going to do is we're going to apply this. We have changed the replica. If I have not saved it, let's do that. We have now increased the replica to 5, and all we really need to do is run this here. Let's see what happens. Do you see what has happened? A lot of changes are going through, okay? Because we had asked for 5 containers, Kubernetes is waiting or is trying to create those specific pods as well. So if we now do get pods, you have 1, 2, 3, 4, 5, right? Very interesting. Let's change it to 2. Let's see now what happens. So as you can see, we're still monitoring this. All we have to do is do that, and certain other terminating changes have started to happen, which means some pods, 3 of them, have started to be terminated, which means at this time, okay, so we still have some pods terminating. In a while, we'll be left with only 2. So if we just keep doing that, we should in a few minutes get back to only 2. I don't know what's going on. Sorry. All right. So yeah, I think that is done now. So if I do kubectl pods, that should be left with 2 alone. So what you've just seen is very, very powerful. What you've seen is to create, increase, or remove anything which is remove a container or remove an executing container. You don't have to actually issue any command. All you really have to do is to make sure that you update your YAML file with the thing that you want to work with. But that is not just this much. Let's try and make a little bit of change in our application and then see how do we make an update into the Kubernetes cluster. So now we know that this is running all of these different pods. They're all based out of this one single image. So what was the image? The image name was called Abhishek Kant Mint Node app, and it was tagged with latest. Okay, so now our manager has come through. He's like, or he or she is like, well, you know what? I don't want you to call it Hello World, which is too boring. Let's call it Hello India. That seems more interesting. All right, so, or let's change that to Namaste India. Well, frankly, it's a trivial change, but now what we want to do is to roll this out into our cluster. Do you remember what? Okay, so we were watching it here at one location. I'll break this. And you will notice when we did kubectl, get pods, we have 2 pods running. And when I go into my browser, all I have to do is run this hello world. So it's still running the old version, right? Okay, we've made a change, which is awesome because now we are saying Namaste India. What we want to do next is to run this image or run this change as or in our cluster. Now, to make that possible, we only need to build this container once and update the YAML file, and that's all there is to it. Well, from a Docker file perspective, you remember I said there is a separation between the configuration of deployment versus the application file. Now, the advantage of that is I don't have to change anything in the Docker file. All I have to do to build a new Docker file is to say docker build -t. At this time, I want to, because it's a new version, I want to use a new tag called v2. So this is just like labeling it. It's creating a new image. It will be labeled Abhishek Kant Mint Node app, but tagged with v2. And here is the Docker file for it. All right, so as you can see, I have a new Docker file or Docker image created. Let's see if there is something new in our images locally. Go ahead and check this out. As you can see, now we have 2 Mint Node apps, but one was tagged as latest. The other one is now the newer one, just created 19 seconds ago, and this is v2. Well, you can actually run it directly as well. You remember the command to run Docker containers, docker run -p. If I run 888, map it to port 8080, run it as a daemon. And what is it that I'm wanting to run? It's called Abhishek Kant Mint Node app v2, right? So it is running on port 888. And if I now go to port 888, I'm just going to open a new tab. Instead of that, if I go to port 8888, I guess, well, that's the new version. It's Namaste India. Well, our cluster is still running 31,000 and it's still giving us hello world. Our changes are available in a new image. And now we want to roll this image into our cluster, which is running on 3100. Okay, what do we need to do? Well, as I said before, in Kubernetes, it's actually very easy to do these changes. All you really have to do, and that's literally all you have to do, is go into this file, pick up the new container that you want to run, which is v2, right? :v2, save it, and kubectl apply -f k8s.yaml. That's literally it. Don't believe me? You shouldn't. Let's check out how many pods are still running. kubectl get pods. Well, there's something interesting happening there. It says 2 pods are terminating and 2 pods are running. So what really is going on at the background is that Kubernetes is actually killing my older 2 pods and bringing up these new pods that are running the new image. So now if I go back and run this localhost 3100, you see the new rollout has happened, which is Namaste India has come back. It was running locally, which is in a single container, port 888, and now it's running in our cluster as well, which is what you've seen. So if you think that it's using the same container, let me actually stop the single container that's running. It's called F419. So the single container is now stopped, but my cluster is still running. You don't have to run the container individually to make this run. I just wanted to show you this because this illustrates that there is a single container and then there is going to be a cluster. So at this time, this 888 will not work anymore, and our individual cluster will continue to function. Well, there are many more such commands. If you actually want to check out, this deployment as well, you can see I can also issue another command called kubectl rollout status of one of the deployments. And what did we call our deployment? Mint node app dash deployment. If you notice, that's how we had named our deployment. And it says, well, this deployment was actually successfully rolled out. Well, let's say I'm not very happy with this rollout. I want to, sort of undo this a little bit. That's, there we go. I can start to roll that back once again. You're getting the power of Kubernetes. There again, 2 old pods, which were running the latest versions, are now being terminated, and 2 new pods, which are running the older version, are now coming online. If I go back here, there we go. Well, we're back to our old trusty hello world. All right. So you've seen we've done a bunch of deployment and we've done all that work to make it run. But now, well, it's the end of the session. Well, it's not really the end of the session, but let's say it was end of whatever we had to do. And I now want to get rid of whatever work I have done. Well, that's just one command as well. k8s.yaml. With that, everything that we have worked on will be removed from our local system. So if now I want to see kubectl get pods in a watch mode, there you go. It's terminating. I'll soon be all over. All right, so this is giving you an overview of how Kubernetes works without giving you any of the theory, intentionally, so that first you understand what we're trying to do,